Basic Skills Day 10, we're going to solve more equations, and we're going to solve equations like formulas for a specific variable. So here's some more complicated, tricky ones, so let's go through how we do this. Here you can see the steps along the side. These are things that you need to do as you start solving more complicated. The first thing to look for is just to see if you need to use the distributive property or distribute. And that occurs when you have a number next to this parenthesis right here. That means you have to multiply that 2 to each of the numbers inside, not just one of the numbers. So distributing, that would make that 2x plus 8 minus 5 equals 2x plus 3. So now we're going to combine like terms. So when I combine like terms, the 2x right here can't be combined with anything else on that side. I can't combine it with this 2x over on the other side because they're not on the same side of the equal. I'm going to have to add or subtract to move them together and get them on the same side. But I can combine the 8 and the negative 5 together. Those are like terms. So 8 minus 5 is going to give me 3. So now I have 2x plus 3 on the left side of the equation, and I have 2x plus 3 on the other side. Hey, wait, do you notice that those are the same? What does that mean? Well, let's just keep going. So now I need to add or subtract to get all the numbers on one side and all the variables on the other. So I'm going to subtract 2x from each side. If I subtract 2x here, it adds up to 0. If I subtract 2x over here, it also adds up to 0. So now I'm left with 3 equals 3. And if I subtract 3 from each side, I'm going to get 0 equals 0. Well, is 3 equal to 3? Think about that. Is that true? Yes, that's true. It's always true. And so in this case, all real numbers is the solution. And what that means is, and we can use a symbol, double bar R, to symbolize all real numbers. But what it really means is that for this particular expression, okay, right here, that any number that you choose, whether it's -1 or whether it's 0.26, it doesn't matter. It will be true for all real numbers. And that's kind of tricky. All right. So let's keep moving on here. So let's see what happens with this one. So for this particular one, again, you can see that I do have the distributive property. So I need to do that first. So I'm going to distribute multiplying this -2 to the 7 and to the -2a. So that's going to give me -14 when I multiply -2 and 7. And -2 times -2a, the sign in front goes with that number, is going to give me positive 2a. Now, if you did it as negative, you have to remember that -2 times 2 gives us, and I even wrote the wrong number. So -2 times 2a would give us -4a, but then we're subtracting that. And so either way, it's going to be plus 4a. So now that is going to equal the other side, 4a minus 6. Okay, so really in this case, we actually had to distribute first. And even though that step's not listed, we still have to check for it. Okay, so now I add or subtract to get all the numbers on one side and all the variables on the other. So I usually like to work with the variables first. So I am going to subtract 4a from each side because that's going to add up to 0. But when I subtract it from this side, now it also adds up to 0. So now I get -6 is equal to -14. Wait, that's not true. So what happens is, that's not true. Okay, that does not equal. -6 does not equal -14. So in this case, it's not all real numbers, it's no numbers fit this description. No numbers work. So in this case, since it's not true, we're going to say that there is no solution. So that happens. And it doesn't happen very often, but it can happen. All right, so let's try one where you actually have to write the equation before you solve it. It says a number increased by 6 is the same as 8 less than 3 times the number. So let's take a look at this. A number increased by 6. So let's call this number x. If it's increased by 6, whatever it is, let's say x was 10. If it's increased by 6, it's 16. What are we doing when we increase it by 6? We're adding 6. Is the same as is your equal sign. So that's your equal. And then the last part is the same as 8 less than 3 times a number. So we have 8 less than 3 times that same number. So what would 8 less than something look like? Well, if the number was 10, 8 less than that would be 2. So what are we doing? We're taking and subtracting 8 from the number. It's 8 less than the number. It's 8 less than not the number, but 3 times the number. So I have to do 3 times the number. So now my equation looks like this. A number, x, increased by 6 is the same as 8 less than 3 times the number. So now it's pretty easy once we get it written. Now we can just simply solve. So I'll subtract my x from each side to get my x's all together on one side. And now I'll add 8 to each side to get my numbers all together. So I get 14 equals 2x. Now I have to multiply or divide to get the x by itself. So I'll divide by 2 and I get x equals 7. All right, so let's go on to some really tricky ones. A formula is an equation that states a rule for a relationship among quantities. What are some you know? Well, I bet you know the circumference of a circle. Circumference of a circle is 2 pi r. Maybe you know the area of a rectangle is length times width, or base times height. So those might be some you're familiar with. You might remember y equals mx plus b, and there's lots of other formulas. Well, sometimes we're going to solve an equation that doesn't for a different variable. So for example, this equation right here is solved for c. Well, what if we wanted to change that and have it be r equals? That's what we're doing when we solve literal equations. I'm going to skip this this question right here, but I'm going to see if you can practice writing an equation and solving it. It's similar to what we did with the 6 more than 8 less than 3 times a number. See what you can do with that and then check back to the notes. I feel like we might be getting long on the video, so I'm going to skip to those literal equations. So a formula is a type of literal equation, and a literal equation is an equation with 2 or more variables. To solve for one of the variables, we use inverse operations. So basically, we solve these literal equations the exact same way we would if there were numbers. So we locate the variable you are asked to solve for in the equation, identify the operations on this variable and the order in which they are applied, and then use inverse to undo them. So for example, we have this formula for density. Density equals mass divided by volume. And if you don't know what that means, it's a formula that's used quite a bit in science, and here's some explanations of that right here, okay? But I'm just going to move on. We want to solve that for m. So we want to solve this. We're identifying the variable we want to solve for. So what we have to look at is if this was m divided by 6 equals something, how would we undo dividing by 6 to get m by itself? Well, what we would do is we'd multiply each side by 6. So that's what we're going to do here. We are not going to multiply by 6, but we are going to multiply, since we divided by v, we're going to do the opposite. We're going to multiply by v. So now what we're going to get for our solving it for m, we get v times d is equal to m. Or you could write it d first. D times v equals m. And now we have solved this literal equation for m. Here's some other ones you might know. So let's try another one. Solve y equals mx plus b for b. So I want to solve this for b. Well, b is being added with mx. So what I'm going to do is I'm going to subtract mx from each side. So now I get y minus mx equals b. So again, I have solved it for b. B is by itself. And I can't combine the y and the minus mx because they're not like terms. They have to be the exact same variable to the exact same power. All right, your turn to try. I want you to pause the video and I want you to try part B. Then start the video again to see if you got it correct. So the explanation for this is we want to solve this for y. So I need to get this part right here by itself. So I'm going to subtract 3x. Since I have 3x's, I can subtract 3x and it will add up to 0. So now I get 4y is equal to 12 minus 3x. Or I could put it as negative 3x plus 12, either way. And then now, in order to get y by itself, I have to do the opposite of multiplying by y. I have to divide by 4, excuse me. But when I divide this side by 4, I have to remember that I actually have to divide both the 12 by 4 and the negative 3x by 4. This is kind of tricky, but what you're going to end up with is you're going to end up with y equals 12 divided by 4 is 3, 3 minus 3/4 x. And you might remember doing this, solving for y, when you worked on linear functions. And a lot of times in that case, we would actually write this as y equals negative 3/4 x plus 3, slope-intercept form. Okay, here's a really good example that involves like something that you might be interested in because it's about grades on tests. It says Ms. Olson's class has had 2 chapter tests. If you scored 88% on the first test and 79% on the second test, what would you need to score on your third test so that your average is exactly 85%? Well, how do you find the average? Well, you're going to add those 3 test scores together and divide by 3. That's how you're going to find the average. So what that means is you're going to take the 88 score plus the 79 score, and you don't know the third score, but you're going to divide all of that by 3 and set it equal to 85. And of course, a lot of people simply guess and check on this, but now we can go ahead and add the 88 and the 79, and that would give us 166 plus our x divided by 3 equals 85. Now we're just going to solve this, okay? When we have 166 plus x divided by 3, we have to multiply by 3 first. So when we multiply 85 by 3, we get 255. So now we have 166 plus x equals 255. So now all I need to do to solve this is subtract 166. And that gives us 89. So our last test score would have to be an 89 if we want to have an 85% average. All right, here are 4 questions where you are going to practice solving for the variable. I will go through number 3 with you, okay? And then I want you to try one and then start the video again. But let's do number 3 together. All right, we have to always look for solving for the indicated variable, which in this case, they didn't tell us, that's why I picked this one, because it's missing. We're supposed to solve it for a. And I forgot that in there. So we want to solve this for a. So just like in that last question we worked on, in order to solve it for a, I have 5 plus a divided by c. So dividing by c, the opposite would be multiplying. So I have to multiply each side by c. So that's going to give me 5 plus A equals 2BC. Okay, now my next thing is, I'm still trying to solve this for A, so this is pretty simple because now all I have to do is subtract 5. So now I get A is equal to, and I can't subtract 5 from 2BC because they're not like terms. So I'm going to have 2BC minus 5. And that is your answer. Okay, you try number 1. Pause the video, give it a try, and then restart and see if you got it correct. I'm solving this for W. So what I need to do is get this whole part by itself, so I'm going to subtract 4 from both sides. Now I get Wx is equal to y minus 4. Again, I'm solving for W, so I have to do the opposite of multiplying W and x, so I'm going to divide by x. Just like in the one we did earlier, we have to divide each of these pieces by the x. So then what's going to happen is we're going to get W is equal to y divided by x minus 4 divided by x. So you can see if you got that correct. All right, pick either number 2 or 4 and solve it. Then restart the video and see if you got the correct answer. If you did not, go back and check the notes and look through the steps to see if you can figure out your mistake. Okay, the answer for number 2, your B value should equal 2A divided by H. And for number 4, N is equal to S divided by 18 plus 20. And that is the end of our Basic Skills Day 10.